Welcome to the Wii Robot Party. We have quite a show for you tonight. I think you're going to like it. As you can see, I just arrived in the Robotaxi, the Cybercab.
Elon Musk is not only building cars, but he's rewriting the entire rulebook of manufacturing. While most automakers are still stuck in assembly line traffic, Tesla just dropped a 50,000-ton Giga Press into the game like it's no big deal. But this isn't just another shiny machine in the factory. This beast can cast the entire frame of a car in 5 seconds. Not minutes. Seconds. It sounds impossible, because it pretty much was until now. So what kind of car can survive a birth that violent and fast? What kind of factory can even handle this level of automation without bursting into flames? And why is this shift such a massive deal for the entire auto industry? To understand this, let's break it all down. The magic behind the Giga Press. Tesla is the first company on the planet bold enough to slap a machine like the Giga Press directly into its electric vehicle production line. No one else has managed to do it at this scale. Other automakers have tried. Some even made noise about launching similar tech. But every time they come close, Musk just levels up the beast, and the gap grows wider. It all began with a 6,000-ton Giga Press, Tesla's first massive die-casting machine. This one was tasked with creating the rear underbody of the Model Y. Traditionally, this section required more than 70 different pieces. Tesla replaced all of them with one solid aluminum chunk. The result? Less complexity, faster production, and a clean break from traditional manufacturing bottlenecks. Then came the Cybertruck. The 6,000-ton machine simply wasn't enough. So Tesla unveiled the 9,000-ton Giga Press. It was specially made to handle the Cybertruck's enormous body, crafted from stainless steel. This version took everything the 6,000-ton did and blew it up, literally and figuratively. It was taller, louder, heavier, and downright terrifying to watch in action. As if 9,000 tons wasn't enough muscle, there's now talk, serious talk, about a 50,000-ton Giga Press. It's not just an upgrade, it's a whole different beast. One that raises a few tiny questions, like why? What car needs that kind of pressure? What are they building? A space shuttle? The new Giga Press is rumored to cast up to 5 vehicles at once. That's not just scaling up production, it's rewriting how we think about making cars. And while Tesla hasn't officially announced what model this 50,000-ton Titan is for, the buzz points toward an all-new mass-market vehicle Musk has teased as the next major chapter for Tesla. To really understand what makes this machine so powerful, you've got to look inside. Here's how it works. The machine starts by melting a special aluminum alloy at incredibly high temperatures in a smelting furnace. That molten metal gets funneled into a custom mold shaped like a vehicle part, usually the chassis. Then the magic happens. The Giga Press applies ultra-high pressure, squeezing the molten aluminum into every corner of the mold, with zero room for imperfections. When the cast cools, what you're left with is a single, flawless piece of aluminum strong enough to be part of a car's skeleton. This process saves money, reduces waste, and eliminates the need for dozens of smaller components. That means fewer welds, fewer robots, and fewer ways for things to go wrong on the assembly line. This isn't just fast. It's the kind of speed that no human can keep up with. Elon Musk pointed out that this Cybercab production line will be moving so quickly, people won't even be allowed near it. It'll function more like a high-speed electronics assembly line than a traditional car factory. There won't be humans loading molds, guiding parts, or checking things by hand. Every step, pouring, cooling, trimming, and inspecting, is automated. It's a blur of molten metal, robotic arms, and split-second decisions. Tesla isn't just building cars, it's building a future where machines are running the show from start to finish. Tesla might have kicked off the Giga casting revolution, but other automakers have started lining up behind the idea. Companies like General Motors, Hyundai, Volvo, Zeekr, and XPeng are all racing to catch up. XPeng, for instance, they dip into the deep end with a 16,000-ton casting machine. Still nowhere near Tesla's 50,000-ton monster, but it shows that the industry sees where the future is heading. However, None of these companies have Tesla's head start, or Elon's flair for pushing boundaries before anyone else has the courage to even redraw the map. It all started when Tesla wanted to reinvent how the Model Y was built. Elon Musk reached out to multiple die-casting machine manufacturers across the globe. Most of them gave the same answer: impossible, too big, too risky. But one Italian company, Idra, was already secretly working on something massive, and by a lucky twist of fate, it was exactly what Musk had in mind. It was a strange coincidence, or maybe just the right kind of madness meeting the right kind of ambition. Tesla partnered with Idra, and the first Giga Press was born. From that point on, Tesla was casting them faster, stronger, and cleaner than anything the auto industry had ever seen. How this giant breathes fire. Even though the scale has changed dramatically, the operating mechanism stays mostly familiar. The process begins with material preparation, where aluminum gets its moment of transformation. Tesla starts by melting down brand new aluminum ingots alongside leftover scraps from previous castings. These go into a furnace powered by natural gas, which is heated to a temperature of about 850 degrees Celsius, hot enough to turn solid metal into glowing, molten lava. Once liquefied, the aluminum is moved through heated pipelines to a second furnace, which operates on electricity and holds the metal at temperatures between 750 degrees Celsius and 850 degrees Celsius. This dual furnace system keeps things running smoothly. One melts, the other maintains, like a fiery tag team for uninterrupted metal flow. Inside this holding furnace, Tesla fills the open space with nitrogen gas. Why? Because when molten aluminum meets oxygen, things get messy. Oxidation ruins purity. Nitrogen solves that by keeping the oxygen out and the heat in. And to go a step further, operators also pump in argon gas, run a rotary degasser, and pass the alloy through a silicon carbide filter. This final step pulls out any particles larger than 25 microns. Tiny, yes, but big enough to cause real trouble in a part that needs to be perfect. After the molten metal is injected into the mold, the cooling phase kicks in. And this is where things get risky. If it cools too fast, air bubbles can sneak in, weakening the final structure. If it cools too slowly, the metal starts hardening mid-flow and fails to fill every edge of the mold. That's why Tesla's engineers obsess over cooling uniformity. Their system manages temperature like it's diffusing a bomb, no room for error. The entire part cools evenly, locking into its final shape with maximum strength and accuracy. Once the mold is fully set, a robot swoops in to extract the component. It trims off the excess material with a kind of metallic precision that no human hand could replicate, then sends the piece down the line for inspection. Every edge, every curve, every millimeter is scanned. The goal is absolute perfection, nothing less. Tesla didn't design this to be flashy, they designed it to be fast. According to Elon Musk, the new production line will be so fast that no human could physically keep up. The line is fully automated from start to finish. No breaks, no slowdowns, just raw, relentless productivity. Each step, filling the mold, cooling it, separating the part, happens in under 5 seconds. Yes, seconds. In the time it takes to yawn, the Giga Press has built the structural frame of a car. And because it's all handled by machines, human error is removed from the equation. There's no manual loading, no guesswork, no mid-process adjustments. Even the layout looks different. When Musk described the Cybercab assembly line, he explained that it didn't resemble a car factory at all. It looked more like something from the consumer electronics world, a high-speed, ultra-efficient operation more at home building smartphones than SUVs. In fact, the line moves so fast that human workers can't even safely stand next to it. Tesla might have started this revolution, but they're not alone anymore. Other companies are scrambling to catch up. XPeng has gone big with a 16,000-ton machine. Volvo, General Motors, Hyundai, and Zeekr have also thrown their hats into the Giga casting ring. Still, none of them are touching 50,000 tons. Not yet. The sheer scale of this machine pushes it beyond the limits of most existing production facilities. Installing one requires more than space. It demands infrastructure changes, power upgrades, safety protocols, and a team of engineers who aren't afraid of blowing up the rulebook. Tesla didn't just invent a new tool, they reshaped how an entire industry thinks about production. Instead of assembling dozens of smaller parts and welding them together, they cast a single giant piece in seconds. That's a structural game changer. It improves rigidity, reduces weight, simplifies production, and slashes labor costs in one bold move. Scaling chaos with robots. Before the Giga Press even thinks about shaping molten metal, it treats the mold like royalty. Each casting cycle starts with a fresh coat of lubrication, around 35 milliliters of soybean oil sprayed evenly across the mold's surface. This isn't just a random industrial habit. The oil makes it easier to eject the finished part without damaging the mold or the product. The system then pulls out all the air from the mold chamber to create a vacuum. Removing air pockets is critical, because any leftover oxygen can ruin the integrity of the final product. Once the air is gone, the molten metal is transferred from the holding furnace and injected into what's known as the shot chamber. Inside the shot chamber, a high-speed piston takes over. This piston doesn't just nudge the aluminum in, it fires it into the mold cavity with incredible force, ensuring every corner, edge, and crevice is filled in milliseconds. Even the piston gets its own touch of maintenance. Before each shot, it's lubricated with about 8 milliliters of oil to keep friction in check and avoid overheating during rapid, repeated movement. After the aluminum is injected into the mold, it's given a moment to solidify. This part of the process sounds calm, but it's anything but slow. The casting cools inside the mold until it hardens enough to hold its shape. Then it's ejected while still glowing at around 400 degrees Celsius. Yes, 400 degrees. And that's when the real cooling begins. The raw, red-hot casting is immediately placed into a cooling bath. Here, its temperature drops drastically, from 400 degrees Celsius all the way down to about 50 degrees Celsius. This isn't just to avoid burning fingers. Rapid cooling helps eliminate internal defects and boosts the strength of the metal. It's a controlled thermal shock that turns a fragile, fresh casting into a usable, durable vehicle frame in seconds. Meanwhile, the mold itself still needs attention. It's not reusable right away. First, it has to be cooled down to about 185 degrees Celsius before it's ready for the next shot. A robotic cleaning system scrubs it down, making sure no residue or metal remnants interfere with the next casting. Within 1 to 2 minutes, the whole cycle starts again. Now, the obvious challenge here is repetition. Casting a single part at a time is impressive, but scaling that up is where things get complicated, and where Tesla leans on automation to the extreme. Inside each casting machine, multiple systems work simultaneously. Elon Musk once explained how they tried doing 5 castings at once. That level of complexity involves not only injecting metal, but also removing every finished piece quickly, cleaning up each mold, and prepping everything again in under 2 minutes. The aluminum, after being cooled and removed, still needs finishing. Any excess metal, those little edges or flash that sneak past the mold lines, gets trimmed off, but nothing goes to waste. That trimmed metal is immediately recycled and melted down again for the next casting cycle. Tesla doesn't just aim for speed, they aim for a closed-loop, zero-waste system. Every frame gets X-ray vision. Once the raw casting is cool, trimmed, and looking like the final frame of a vehicle, it doesn't go straight to assembly. It heads into a quality control process that sounds more like something out of a spy movie than a car factory. Each piece is X-rayed, internally scanned, checked for cracks, bubbles, or any defect invisible to the naked eye. These castings are structural. They can't just look good. They have to hold together an entire car, even under the pressure of high-speed travel or a crash. If anything is off, the part is rejected. That means Tesla isn't just relying on external inspections or surface checks. The internal structure has to be flawless. It's this relentless quality filtering that keeps structural failures at bay and ensures that the part performs the same way in every single vehicle. In the high-stakes world of giga casting, the mold isn't just a container, It's a pressure cooker holding back a literal flood of molten aluminum. One of the biggest challenges during casting is making sure the mold doesn't burst open when the aluminum is injected at insane speeds and pressure. The force involved is so intense that the machine has to clamp the mold shut with overwhelming strength. If it slips, even a little, it's game over, scrap metal and a multi-ton mess. This is where the 50,000-ton Giga Press steps in like a mechanical bodybuilder on steroids. It applies a clamping force so massive it borders on absurd, holding the mold in a death grip while molten aluminum is fired into it like a liquid missile. There's no room for error here. Everything has to be locked, synced, and cooled in record time. Elon Musk once described this process in his own way. He pointed out that they had to figure out how to jam molten metal into the mold and then cool it down really, really fast. Emphasis on really. Because when you're working with materials that could melt a hole through the floor, milliseconds matter. To make all of this possible without the entire setup melting down, Tesla didn't just rely on brute force. They built an entire system around precision. An ultra-fast cooling process kicks in right after injection. This isn't your average industrial fan setup. Tesla developed a conformal cooling system, cooling channels that curve and follow the exact shape of the mold, so every corner gets cooled evenly and efficiently. That's how they were able to cut casting cycle times drastically. Back in 2020, it took around 170 seconds to complete one cycle using the 6,000-ton press. Now, it's down to 75 seconds. That's less time than it takes to microwave a frozen burrito. These faster cycles mean more cars, more parts, and more consistency. But cooling wasn't the only upgrade. Tesla also designed a smart mold release system that knows exactly when and how to eject the parts safely, avoiding cracks or warping. Every piece gets handled like a delicate sculpture, even though it's a chunk of solid aluminum. Say hello to AI on the assembly line. Tesla didn't stop with the mold. They brought artificial intelligence straight into the quality control process. After casting, every part goes through a fully automated inspection that uses machine vision and deep learning to detect flaws. This isn't just a camera scanning the surface. It's an AI system trained to understand the internal structure of a casting and predict where problems might hide. This level of quality control is unheard of in traditional auto manufacturing. Most companies rely on human inspectors or basic sensors. Tesla uses something more like a medical imaging system, scanning each component like it's prepping for surgery. That's how they catch microscopic cracks or voids that could cause problems years down the road. It's this kind of innovation that pushes Tesla into new territory. What they've built here doesn't look like a car factory anymore. It looks more like an electronics manufacturing facility, fast, streamlined, and ruthlessly optimized. These casting upgrades aren't just for show. They've already made a difference in Tesla's vehicles, especially the Model Y. Tesla's head of design, Franz von Holzhausen, and VP Lars Moravy recently revealed that the rear Giga cast section of the new Model Y has undergone major redesigns. The new rear underbody is around 7 kilograms lighter than the previous version. That's about 15 pounds shaved off in one move. It might not sound like much, but in the automotive world, every gram matters. Less weight means better performance and longer range, but it's not just about speed or efficiency. The new design also improves structural rigidity, reducing body twist during sharp turns and giving the car better handling overall. And machining time? Slashed in half. The redesigned casting now requires 50% less machining to finish. That means fewer robots, fewer steps, and a much faster trip from molten aluminum to a drive-ready vehicle. Lars Moravy also highlighted how Tesla's conformal cooling technology played a huge role in making this possible. Instead of using straight-line cooling channels, which often leave hotspots and slow down the process, Tesla engineered molds where the cooling lines curve and bend to follow the mold's shape exactly. This change is why cycle times have dropped so dramatically. With the faster 6,000-ton press, they were able to trim the process from almost 3 minutes to just over 1. That's not just good for production speed, it also means more consistent parts, fewer defects, and a smoother ride for customers. And yet, there's one big question that's been bothering everyone in the EV world. Why hasn't Tesla used front Giga casting in the new Model Y? After all, they pioneered the technology. It would make sense to include it in one of their flagship vehicles. Strangely, they didn't. Most Model Y units are still made using stamped sheet metal for the front section. Only Giga Texas and briefly Giga Berlin experimented with a structural battery pack combined with both front and rear Giga castings. So why the hesitation? According to Lars, it came down to global consistency. Tesla wanted a unified body design that could be produced the same way in any of their factories worldwide. This reduces supply chain complexity and avoids regional design headaches. If one part is interchangeable across factories, it's easier to manage production even when shipments are delayed or suppliers hit a snag. Still, the decision not to use front Giga casting in all locations surprised many. It's a technology Tesla themselves brought to life, and yet they chose not to commit to it across the board, at least not yet. Even without front Giga casting, Tesla's approach to vehicle design is reshaping the industry. They've managed to make the Model Y lighter, stiffer, and faster to produce, all while improving safety and performance. Their decision to reduce weight by 15% on the rear casting alone is proof that small changes can have big impacts. What makes this process so fascinating is the mix of brute force and surgical precision. Tesla uses a machine the size of a small house to slam molten aluminum into molds, but they also fine-tune every cooling channel and teach robots to inspect every detail. It's this balance that sets them apart. And while the front casting remains a question mark, there's no doubt that Tesla's casting technology has already left its mark. With each generation of vehicles, the process gets faster, the materials get stronger, and the designs get smarter. The only real mystery now is how far they're willing to take it, and whether anyone else in the industry can keep up. Why Tesla's Cybercab might be the most efficient car ever built. The future of car manufacturing might not roll off a traditional assembly line. It could simply drop from a robot-powered beast of a machine in just 5 seconds. And it's a very real possibility Tesla is chasing down with its upcoming Cybercab, as confirmed by expert Luca Greco and the YouTube channel The Limiting Factor. Tesla's been quietly reserving a massive amount of casting capacity for this project. That's right, Tesla didn't forget about the Cybercab. It's literally building a whole new way to make cars, starting with this one. Elon Musk didn't hold back when he explained how fast the production process could get. He envisioned a time when a new car could roll out every 5 seconds, not 35 seconds, like the current speed at the Shanghai Gigafactory, which, by the way, is the fastest production line in the world, but 5. It's an outrageous goal by today's standards, but not impossible given what Tesla is building behind the scenes. What makes this possible? The real game changer here is the Cybercab's one-piece cast design. While traditional cars like the Model Y are built from about 200 structural components, the Cybercab reportedly cuts that down to just 80. That's more than a 60% reduction in parts. Fewer parts mean fewer things to weld, fewer opportunities for something to break, and a drastically simpler assembly process. It's like trading a 1,000-piece jigsaw puzzle for a wooden toy block, way easier to deal with and much faster to finish. Engineers working on the Cybercab say the structure is so optimized that it doesn't even need traditional assembly lines anymore. There's no back and forth of human workers bolting one thing at a time. Instead, the car is cast, cooled, inspected, and moved along by AI-guided robots. You're not watching a car being built step by step. You're watching it appear, already half-formed, like something out of a magician's hat. Tesla is building a new kind of car factory. This isn't the classic image of an auto plant, with conveyor belts and welding sparks flying in the background. Instead, it's more like a robotic dance floor, where high-tech machines and artificial intelligence work 24/7, with zero coffee breaks and no union drama. At the heart of this operation is Tesla's 50,000-ton Giga Press, an industrial monster capable of casting massive sections of a car in one shot. The real innovation, however, isn't just the Giga Press itself. It's what Tesla has done around it. Elon Musk's team designed an ultra-fast cooling system to solidify the aluminum before it deforms. a smart mold release mechanism to get the part out instantly, and an AI-powered inspection system that catches even the tiniest defects. These systems are all synced together to create a seamless flow of production, like gears in a finely tuned clock, except the clock spits out futuristic cars. At this pace, Tesla might have to actually slow down production, not because they can't keep up, but because the rest of the supply chain and market might not be ready. Musk himself once noted that if they truly achieve 5-second production cycles, Tesla will have to sandbag their numbers, meaning they'd intentionally limit output to keep things manageable. Still, even a toned-down version of that scale is game-changing. The lower production cost means the Cybercab could hit the market with aggressive pricing, lower cost, higher margins, and endless scalability. It's the holy trinity of manufacturing dreams. The Model 2 joins the club. But the Cybercab isn't Tesla's endgame, it's just the proof of concept. The real prize is the upcoming Tesla Model 2, the much-hyped affordable electric vehicle that could finally turn the EV market upside down. Sources close to the project suggest the Model 2 will use the same one-piece casting concept as the Cybercab, just with a few extra features like a steering wheel, pedals, and seating for 5. The goal is to bring down production time for a full-featured EV to just 10 seconds. For perspective, most legacy automakers take several hours, sometimes even days, to fully assemble a car from scratch. Even if Tesla misses that 10-second goal by a few seconds, the savings in time, labor, and material waste are enormous. It's not just fast, it's absurdly fast. Some might wonder, what's the big deal about building a car in 5 or 10 seconds? Sure, it's impressive, but does it change anything? The short answer is yes. Fast production means higher volume. Higher volume means lower prices. Lower prices mean more people can afford to switch to EVs. And that means Tesla eats up more market share while keeping competitors chasing shadows. Even in Q1, with EV sales across the board taking a hit, Tesla remained untouchable in the US. It sold 64,051 Model Ys, down from last year, but still the highest of any EV model. Meanwhile, the Model 3 surged with over 52,000 units sold, up more than 70% from the previous year. The Model Y's slight dip might just be because buyers were waiting for the new upgraded version. Either way, Tesla's top 2 models outsold most of the industry combined. Even the oddball in the lineup, the Cybertruck, cracked the top 10 with 646 units sold in the quarter. Model S and Model X also pulled in decent numbers, despite being high-end luxury EVs in a niche market. While other automakers are struggling to balance demand and production, Tesla's fully integrated approach continues to steamroll the competition. All this speed and efficiency wouldn't be possible without Tesla's decision to redesign not just the car, but the entire factory model. Instead of the traditional mile-long assembly line, where parts are added piece by human workers, Tesla uses a modular build process. It's like assembling a Lego set, just at scale, with robots doing all the snapping together. Musk once compared it to building toys, except these toys weigh a couple of tons and run on electricity. It's a method used in small batch casting, like when they make 100 Matchbox cars from a single mold. Tesla just made that mold bigger, a lot bigger. Behind the scenes, Musk reportedly refers to the Giga Press area as the Cathedral of Casting, which sounds dramatic, but also kind of accurate. There's a reason no one else has done this. Casting a vehicle body from molten aluminum is incredibly hard. The process needs to be precise. The metal has to be injected at high speeds to fill the entire mold without creating air bubbles or cooling too early. A slight error can ruin the structural integrity. Now imagine doing that at scale, under pressure, inside a machine that weighs more than the Statue of Liberty. This is what makes Tesla's manufacturing story so compelling. It's not just about building EVs, it's about building the machines that build the EVs, and then making them faster, smarter, and more robotic than anything else on the planet. That's the world Tesla is creating. One Cybercab every 5 seconds, one Model 2 every 10. One fully automated, human-free future inching closer with every molten pore. What Tesla is doing is about tearing up the manual and coding a whole new system. The 50,000-ton Giga Press The 5-second chassis turnaround, the fully automated production line. This isn't sci-fi anymore. It's a real-life factory that behaves like a high-speed algorithm, replacing decades of slow, manual labor with precision, pressure, and molten metal. With the Cybercab and the whispered arrival of the Model 2 riding this wave, Tesla is redesigning the racetrack while everyone else is still lacing up. And while the rest of the industry is still figuring out where the keys are, Tesla's already miles down a road it built from scratch.